Hi, hope you guys are doing well. In a previous video, I carried out some tests with a 775 DC motor to show you that the specifications provided on Banggood website couldn't be correct. Actually, the results we got are way out of the specifications. Since then, I've received some comments about the way the tests were performed and also some requests which I would like to answer as soon as possible. So in this video, let's answer some of those questions and have a look at what we've been doing to get a better understanding of the performance of those motors. So let's get started. First of all, let's have a look at the comments regarding to the way we performed the tests. Iron 322 said, I think Banggood tested the motor without load. Please remove the motor load and test it back again. Let's see the difference. Thanks. Noivong Taylor said, I think factor measure current at no load. Your measure with the load. The red disc with 4 slots. Well, the load the guys are talking about is the disc we used hooked up to the motor shaft in order to get the RPM of the motor. As I've got no contactless tachometer, this disc was the way I got to take the speed readings. I answered in the comment section of that video that this disc was 3D printed and it is really light. You guys can see here that it weighs 9 grams and shouldn't play a big role in the current measurement. Anyway, let's see how it works in practice. I've got 6 of those 775 DC motors. 2 of them are placed in my RC car. I've got 4 of them we can play with. You guys will be surprised with the results. So, let's begin. Here is the first motor we are going to test. I'm gonna place all of them in this holder and we can start the tests. Please note there is no load attached to them. I will be using 12 volts to test all of them. So for this first motor, we are reading 950 milliamps at 12 volts. If you guys remember, we got 1.25 amps in the previous video. Let's measure the second one. So for the second motor, we are reading 850 milliamps, so a little bit lower than the previous one. Let's jump for the third one. For the third one, we are reading 1.15 amps. So let's measure the next one. You guys can notice that the noise of this motor is completely different of the previous ones. Let's have a look at the current rating. And the current rating is also way different. It's 250 milliamps, quite lower than the previous motors. Let's have a look at the results. The test voltage was 12 volts for all of them, and you got the current readings. For the first motor, we got 950 milliamps. For the second one, 850 milliamps. For the third motor, we got 1.15 amps. And for the last one, 250 milliamps. At this point, you guys might be wondering what's going on. Why physically similar motors have such a different performance? I guess the answer is trick. Even they look the same, they might be different models of this motor. Even I have got all of them from the same provider, Banggood in this case, they might be different models. Let's Google about the specifications of this motor and let's see what we get. I had a look at many different specifications for this motor from different providers. In this video, let's see an example. Here we have a 775 DC motor provided by DSD motor. As you guys can see, it weighs 350 grams, the same as Banggood one, and has got the same dimensions. Despite the label they put in the motor, it's physically identical to the motor we got from Banggood. But here in the specification sheet, you guys can see that we have different models. Even they are all physically the same, but they are rated for different voltage, and they also have different current at low load, at maximal efficiency, and stall. Some of them at 12 volts have got 900 milliamps, the same we measured for one of those motors. Some of those motors can even reach 35 amps at stall torque, or at 12 volts 13 amps or 14 amps. The lowest current for 12 volts is this model is 220 milliamps. So when you get one of those motors, if the provider don't tell you which model you're getting, you can't really know the specification of your motor. And I guess Banggood has got many of those motors, different models from different providers, and they mixed all together. So when you buy one of those motors, you don't really know which model you are getting. Now let's have a look at one more comment. RevScott58 said, could the rated specs be outputs if the motor were being driven at the rated RPM as a generator? As I answered in his comment, I don't believe that Banggood would provide the specs of DC motor as a generator. However, let's see that in practice. I printed a couple of motor brackets and fixed the motors in them. Then I prepared this motor coupler to connect them together. So as you guys can see here, I have already connected the motors together, and I fixed the motor brackets in the base. This first motor is connected to the power supply, so I have here this switch where we can turn the motor on and off, and we also have the power meter where we're gonna be reading the voltage. It's already set to 12 volts and the current. The second motor is connected to a 12 volts lamp bulb, and I will be using a clamp multimeter to get the reading of current. So let's start our test. As you guys could see, with this load, the motor was generating about 270 milliamps. The specs on Banggood website says at 12 volts 140 milliamps, and actually at 36 volts 200 milliamps. So the answer is no. I don't think these specs are related to this motor acting as a generator. Anyway, now let's measure the voltage this motor generates. So it generates about 8 volts with the first motor at 12 volts. Now let me show you the data related to the first motor in this situation. So it was 12 volts and 3 amps input and 8 volts 300 milliamps output. Now let's have a look at one more comment. It's actually a request. Republic of Tutorial said, "Very nice video. Please can you make a video for testing its torque? In the website it's written 2 kg/cm. Is that true? Can you test it and show us the real torque? Thanks." Well, I thought I could answer his request really fast, but when I started testing those motors, I had a couple of problems, and I will show you. So first, let's have a look what I've done so far, and let's discuss about some issues. The first thing I'd like to show you is a good specification. Here we have one from AliExpress. That's for 775 DC motor as well. So let's have a look what we have. As you guys can see, torque is not just a number. It's related to the voltage, RPM and other motor characteristics. So all of those parameters are actually a curve and not just a value. So as you can see here, at no load we have no torque, at stall You can see the torque information here at maximum efficiency. You can also see the value for the torque and at maximal output power. So the best way to understand a motor performance is plotting those curves. So let's see how we can do that. So the easiest way to analyze the performance of a DC motor is to have specific equipment and software to execute this task. They will analyze the motor and plot all the curves for you, but they are quite expensive. I'm talking about thousands of dollars. So let's see how we can do ourselves something to perform this task. The most difficult information to plot the performance curves is the torque. And here in this picture you can see a solution to get this information. We connect an arm to the motor shaft. We know the size of this arm, it's going to be our distance, and the torque is going to be force times distance. To get the force, we can connect a scale in the end of the arm. The other informations we need are input power, current, and input power is current times voltage. Output power, that's torque times speed. We already know how to calculate the torque, and also we know how to get the speed readings. And the efficiency is going to be power out divided by power in. When you get ready, we can put all the information in an Excel file like this, and after it's going to be easy to plot the curves. To perform this task, I prepared a wood structure, printed all the needed parts, and I put them together. As you guys can see, I connect the arm to the shaft with those two screws, so we can vary the pressure pressing those screws. So it will affect all the parameters of the motor's current, as speed and torque. Then I connect the end of the arm to the scale. The first issue I had was related to the scale. The scale couldn't read the measurements smaller than 20 grams, so I decided to print a smaller arm to get stronger torques. However, it didn't fix the problem in the beginning of the range. For small torques, the scale just refused to work. Applying more pressure to the arm, the scale could read the values. But then we got a second problem. Friction between the shaft and the arm was melting the PLA the arm is made of. So to solve both issues, I decided to use wood, and instead of hanging scale, a more precise kitchen scale. This one can read 1 gram. Let me show you how it will work. Well, the last issue I have is the limitation of my power supply. My best power supply is rated to work up to 15 amps, and as you guys can see here, when I have this motor working a high value torque, and we can do that applying pressure in the shaft, the power supply reaches its maximum current. To solve this issue, I'll be using a battery I took from this jump starter. It can work up to 1700 amps peak and should do the job. Now I have to perform all the tests and post a new video with the results. I hope it will be enough to draw all the curves like this one provided by AliExpress. Before finishing this video, let me show you one more thing. I will be placing this motor in my RC car instead of the 2775 DC motor. I need more power in this car, and I will be doing that, and I will show you in the next videos. So that's it guys, I hope you guys like this video. If yes, please thumbs up, comment, and I will catch you next time.